Great. Well, thank you. I really appreciate the opportunity to speak today. Can you hear me in the back all right? Is this good volume level? Great. This is a talk about entity resolution. It's kind of an obscure topic when you actually dig into it. It has a lot to do with understanding about identity, usually about people and organizations. We'll dig into that. I'm going to talk about a range of kinds of use cases. So we do a lot of work with organizations that are fighting against fraud or human trafficking or any sort of badness you can imagine in the world. But we also do a lot of work with customers that are looking for their best customers. And frankly, a lot of the similar techniques are used in both cases. And I want to try to illustrate that, but moreover, show how what we're doing is a component of the practice of building a semantic layer. How does that fit in? What does that mean for your practices? And a little bit of background about who I am. I made the mistake of going into grad school in AI back in 1983, and I got to work. My advisor was Doug Lennett, who did really early work in generative AI, and actually got a lot of flack for some of the early work. If you look at Eurisco and AM and some of those, it's interesting to see how this has come back around. While I was there, I was very interested in working in, of course, machine learning that we were doing, but specifically natural language, a lot of linguistics, and then from there I got involved with neural networks. So hearing what the dialogue is today about Gen AI, deep learning, language models, it's really fun to see what this has come around. I went out to Bell Labs, and I worked briefly for a team. It was led by John Hopfield. So he shared the Nobel Prize in Physics recently with Jeff Hinton in deep learning. I got to be on that team for a bit. And then I went and did a lot of work in cyber and network engineering. And because of that, I got called up by some friends in Seattle. They had a new thing. We were going to try it out. You know it as AWS. So one thing led to another. I got to lead the #3 project for 100% cloud architecture after Amazon. And based on doing that and optimizing Hadoop to run in the cloud, I got called into Berkeley to give a lecture. And it was the team that was doing the first academic paper about cloud computing, led by Jan Stojka and Dave Patterson and some others. If you look at the video from that lecture, the people sitting next to me, they were all graduate students at the time. Several of them are billionaires now. I am not. But it was really fun being on executive staff in the early days of Databricks. And I've heard a lot of things about Databricks and AWS today, which I think are all valid criticisms. My apologies, mea culpa, for any part that I had and any pain that you had. I since then got to work on some other open source projects, for instance, Project Jupiter, and some of the involvement, large-scale usage for the intelligence community in the US. And then now I am at Senzing working on entity resolution. And so I'd like to just showcase a few points about investigative graphs. I think that this is a really interesting topic that maybe should get a little bit more purview. Yeah, you can see here the raccoon getting a weapon. But it really does illustrate what we're talking about in terms of finding networks of criminal activity, but also how similar techniques are useful for finding your best customers. So a little bit of background here. There's some really fascinating work by Oliver Bullough and Ann Applebaum, Carol Cadwalader, people who have been investigative journalists looking at essentially the rise of the oligarchs, the rise of kleptocracy, what's been happening in the world, looking at tax havens, looking at how the laws are being changed. There's also a really fascinating series of work from ICIJ. Of course, you've probably heard about Panama Papers and Paradise Papers and all these. I would recommend my top pick is definitely Ray Blake and Graham Barrow, who do the Dark Money Files. If you haven't heard that, it's like a condensed version of learning how to become a money launderer. And also Graham Barrow almost became the 5th member of the band Queen, so he's really entertaining. So a lot of badness in the world, but a lot of interesting insights about how this happens. There's one case I'd like to point out. It's called the Azerbaijani laundromat. Have people here heard of this? Azerbaijani? A few have. So the idea is that over a period of just a few years, about $3 billion of money laundering came out of one branch, the Estonian branch of Danske Bank. And it involved almost 500 different shell companies. So there were 400 and change shell companies that were used for layering, essentially changing up the money so it's hard to trace. And then there were another 4 companies which were involved as deals, basically when the money got drawn out. Those were all UK registered companies, but not operating in the UK. And the interesting thing here is this Danske Bank, of course, has taken a lot of criticism for this, but what was found out later on subsequently that upwards of $800 billion in money laundering went through that branch. And it was primarily 4,000 non-resident accounts, mostly Russian. And in fact, the Russian central bank had notified regulators in the US and EU twice, saying, hey, we think something's going wrong over here in this branch. You might look into it. It was right after the 2009 global crisis. And this particular bank didn't have a lot of loans. They had a whole bunch of capital coming in. As far as banks and regulators are concerned, they were a case study in what they wanted to see. So EU and US both said, no, we think it's fine. And after hearing that twice, the Russians turned on the flood, and hundreds of billions of dollars, euros, in money laundering went through. It's an interesting thing, especially because we wouldn't have known about it, except that one of the one member of Danske Bank, he was actually British, but he had noticed that there was involvement from a company called Lantana Trade. Anybody ever heard of that before? It's the investment vehicle for the Putin family. And so when he realized they were holding this hot potato, that's when he blew the whistle, completely destroyed his own career, but basically leaked out 17,000 transactions, and out of that, 4,000 transactions were the money transfers regarding about $3 billion of money laundering. There's a really interesting interactive display. I don't want to obscure this here if you can't see it, but the Sentry, based out of Washington, D.C., has a really interesting interactive exploration of this example, particularly the Aliyev family, which is one of the main families that was taking kickbacks from Russian trade of weapons. They were taking kickbacks under the table, also stolen assets from the Azerbaijani state, and then funneling that out into buying luxury goods, bribing officials, et cetera. So if you want to check this, it's actually based on Lincurious here. It's a really good resource for exploring it. Also, another one that's similar to this is the whole saga of Roman Abramovich, which has been in the news cycle a lot lately. But this is what ICIJ was calling Cyprus Confidential. And it's a network of essentially avoiding VAT taxes, a lot of tax evasion, a lot of money laundering. And it really illustrates the fact that, to quote from John Lambert from Microsoft Threat Intelligence, defenders think in terms of lists. People who are responsible for defending think about checklists. Attackers think in terms of networks. And from what Lambert's famous quote says, as long as the attackers continue to think about graphs and nobody else does, the attackers prevail. Because the problem is when you go to commit these crimes at scale, this is really industrial scale for criminal activity, you never have a through line that's linear. Right? You go out, you try to exploit some vulnerabilities, you run into a wall, you pivot. And so ultimately, these kinds of criminal behavior are always a graph, right? That's how they get through. And the scope of the problem is, we see right now just for the B2B transactions of essentially dark money flows, we're seeing about $3 trillion a year, and it's evenly split. A trillion each between the Americas, EMEA, and Asia-Pac. And along with that, also you see drops in some places. Like in UK now, there's been a drop in violent crime rates, but there's a big rise in terms of fraud. So more than 40% of all crimes in England and Wales are fraud. And, the idea is that rather than going out on the street and pulling a knife on somebody and demanding their wallet, it's much easier probably to sit in a coffee house and use your laptop to steal somebody's bank account. So we have a big problem with this, and this is not even taking into account, for instance, other kinds of financial flows, like crypto coins are not really even registered here. And the challenges for investigating this largely come down to the fact that the computing tools just haven't been there. If you're a frontline investigator and you're trying to determine are these transactions involved in some sort of fraud network, if you're just looking transaction by transaction, you'll never be able to reconstruct that in your head. And these people are under a lot of pressure to do a lot of work. Like I mentioned before, $3 billion went through essentially 4,000 money transfers in the Azerbaijani laundromat case. So as a human trying to understand all those transactions and piece them together, it's impossible. It's beyond human scale. And so a lot of what we need to do is to bring that back to human scale, have the computing tools, have the conceptual tools to be able to enable the computing tools so that analysts can do their jobs even in the face of the criminal activity increasing year after year. In this case of Azerbaijani laundromat, it was really only 2-3 years. So far, I believe there's only 2 people who've been indicted and put into jail in Germany. That was the first cases that came earlier part of this year. They went to court. And now there are a few people who have been prosecuted, but there are a lot of people in the EU who are paid off. And in fact, I believe there's one MP in Italy who's still bragging about receiving 8 million euros in bribery and claiming that he'll never get caught. So the way to go about this conceptually, I really love this model here. This is from a talk. Friedrich Lindenberg is from Open Sanctions in Berlin. And then Boris Kozovsky is one of my colleagues at Sending. And Christoph Williamson is sitting right over, or was sitting right over here. So talk to Christoph about it. They had a really, really great presentation here. But the idea is to have a model. So when we're talking about semantic layer, here's the idea of a conceptual model for approaching investigative graphs. The idea is on the left-hand side, you've got some kind of risk data. So this might be sanctions or watch lists or politically exposed persons, but some kind of history of badness. And then on the right-hand side, we've got event data. This is payments, wire transfers, et cetera, log files. Frankly, the event data is often very confidential. It really doesn't get out into the open very much. In the case of Azerbaijani laundromat, we're really interested in that because there we have, in the wild, thousands of transactions that represent what is being done by these networks. In the middle, though, you've got link data. And so this is where you can track beneficial ownership and really see the connectivity between the other categories of data. How can you start to put together a graph? How can we have semantics to apply to these categories of data to build up graphs to attack this? So open sanctions, if you haven't seen it before, there's almost 250, and it's growing all the time. But there's a lot of data sources they pull together to make this open data set to be able to research risks that are known from people and organizations. And for the link data in between, there's open ownership, open corporates. There's the LEI identifiers. GLIFE does the global LEI index, which was one of the outcomes from the 2009 financial crisis. ICIJ and others, there's a lot of really good, interesting data for linking together the parts. On the event side, though, as I mentioned, there's not a lot. OCCRP is an organization that accepts leaked data from whistleblowers. So in this case, this is where all the PDFs went. And so they do have this really great data set that Friedrich and others helped put together. I think Graham Barrow is actually involved in some of that analysis as well. Otherwise, we really look to a lot of synthetic data, as was mentioned a little bit earlier today. IBM has AML Sim for doing a synthetic data generator for money laundering. It's a little bit more tilted toward credit cards, but it can be used. I've been working with some colleagues to be able to come up with essentially using the graph patterns that we've seen of known fraud tradecraft and be able to use that to simulate and then generate synthetic data so that we can use this to build graphs and test out algorithms, et cetera. So there's a little bit of hope there. Now, the top is being clipped a bit, but the title of this is Entity Resolution. As far as Sensing is concerned, you may have never heard of us before, but you've probably used us. I imagine that most people in the room have used the Entity Resolution, what our SDK is being used in a lot of places across the world. And to describe it, the idea is that you're taking and merging together disparate data sources. So 2 or more data sources, and you have multiple PII features, name, address, telephone number, birthday, tax ID, et cetera, et cetera. And the problem statement is that you want to find a consistent footprint across your different data sources for each entity. So for each person or each organization, find that footprint that identifies them. And the trouble here is really about identity management. So if you have formal relationships with people and organizations, they're your customers, they're your vendors, somewhere in your databases, you've got a fragment, at least, of their identity. I mean, you have to. And if you don't, IRS, HMRC, RevCan will probably want to have a conversation. So there's some kind of ground truth for who it is that you're doing business with and how you identify them. The trouble, though, is, for instance, if you're a bank and you're trying to respond to regulatory compliance, you're going to have to purchase data from Dow Jones, from Moody's, from Sayari, et cetera. And so you may have your customer database from one part of the bank, but then you've got another part of the bank that's maybe doing loans, that's doing something else. Do those align? You're not sure. As you're bringing in data from Dow Jones or Sayari, do those align? Definitely not. There won't be foreign keys. So the problem is, how do you pull these different pieces of identity back together? And the trouble here in the diagram is that if you're looking transaction by transaction, the trail gets lost, right? If you're just looking at Bob Smith II and then Robert Smith Jr., and then Bob Smith with a flag because he's known to operate under an alias, Bobby Jones. If you look at those three, you can say, okay, well, there's some common points. But then a new record comes in for Bob Jones, and he shares some information. I guarantee in production you won't pick that up. And so what we're doing is essentially taking these different features, looking across the different data sets, and then triangulating on them to provide a kind of overlay. You could call it a semantic overlay if you want, to say, here's the evidence to support this individual, Bob Smith, at 123 Main Street. But then also, here's another record for a Robert Smith. We don't have enough evidence yet to say that they're the same person based on the risk tolerance for your organization, but we can say that they're a lead. We can say that they're probabilistically connected. So the idea is if you are doing some sort of threat investigation, those are hot leads to follow. If you're looking at marketing opportunities, those are also hot leads to follow, right? If you're looking at householding or something like that. The thing that really compounds it, though, is when you start to look at globalization. So we'll show some cases here in a bit, but when you're looking across the world and you have data sources that are coming in different languages, addresses that are coming in from different regions, there's a big problem to try to align those. And that's a lot of the work that we do. And a lot of that is actually culturally based. It's informed by cultural norms. So this is more of a linguistic problem and a cultural problem. It's not just a fuzzy matching problem. How many people here have ever seen a movie called 21? Stars Kevin Spacey. So, okay, great. We were the bad guys in that movie. The team has been together. The founders have been together for 30 years. The core engineering team has been together for 25. This is Jeff Jones. This is Jeff Jonas, our CEO, and he got his start at the Mirage Casino in Las Vegas even before they opened. And so a lot of our stuff was proven out in the casinos in Las Vegas. And then eventually IBM acquired the company, and then we spun out in 2016. And talking about the movie 21, this was something that happened from one of our early demos. Actually, there was a member of, I shall say, a human investigator in the US. And they were at the casino. They were looking. There was an individual who's in organized crime who was blocked from being able to go to the casino. And if he had been let in the door, the casino could lose their gambling license. And what we were looking at was something called non-obvious relationship awareness. So not just, how do your records match, but really what's the context behind your records. Like, for instance, it might be that somebody from the bad guy list is living in the apartment next door to a person who's a manager in your casino. And maybe there's something untoward going on, some money being slipped under the table. As it turned out, when we did one of our early demos, this individual who was on the top of the list to be blocked from the casino because of organized crime happened to be having lunch with the DBA for the casino, which basically they said, thank you, the demo worked well, excuse us, we have to take care of something, but we'll be right back. So that's kind of showing what we do. And it's a small company. We're over 30 people now. 40% of what we do is in public sector. About 60% of what we do runs in air-gapped environments, so usually highly secure environments. And here's an example, I think, that probably illustrates it. If you've got Bob Jones over there, and he's known for having done money laundering before, there's a kind of tradecraft called channel separation, where a person will go in and they'll start creating other accounts. And each time they create an account, their PII drifts a little bit. So, Bob Jones comes in, he might change maybe his name, but he keeps his address. And he just keeps changing and changing and changing until finally, in the middle, he's opened up a new account with almost an entirely different identity. So the problem is, if you're a bank, how can you track that trail, that audit trail, to say, no, actually Bob Jones, Robert Smith here, who's opening a new account, he's actually Bob Jones. We know him. He's on a watch list. You need to block this now. You need to take action. So that's the problem. It's compounded by the fact that, again, globalization comes in. So I studied Arabic a long time ago, and my pronunciation is horrible, so my apologies if I don't say it correctly. But if you have this individual, Abdullah Qadash, if I translate, depending on the dialect, from Al-Lughat al-Arabiyya into, say, English, that could go 5 ways, depending on the dialect, and they'd all be legitimate. And if Abdullah has made a pilgrimage, he'll have a prefix al-Hajj. If his parent is famous, he might have a suffix like bin Amir. Here's a nickname, Abu. And so all of these are valid representations. So you can imagine that trying to just do like a fuzzy match on the name strings, it's going to fail. And when you look at nicknames in Russian versus nicknames in Arabic versus nicknames in Korean, this problem becomes very, very, very much compounded. So if you have some data sets that are maybe drawing on information that's in Arabic, other data sets that are drawing on information in Italian, others in English, you try to align those, it's a huge problem. But then conversely, down at the bottom in English, you've got John R. Smith and John E. Smith. And if I were looking at voter reg, like for instance, the majority of voter registration in the US goes through our SDK for validation, verification. So for voter registration, those would be 2 different people, even though it's really only 1 letter different. So it's a really difficult problem because of cultural norms. Cultural norms really dictate the kind of comparisons you have to make. And addresses can be even harder. This is an address in Singapore. The problem in Singapore is you have a confluence of Chinese, Malay, and British culture. And when you look at the address systems there, they use fragments of all the different cultures and they mix and match. And this isn't, I know where this is. I've driven by there. I will say that I'm not a customer. If you are involved in fraud analysis, this address shows up a lot in terms of bribery reports. It's a famous bordello at Orchard Tower. But the 2 representations of it, up at the top, they're completely different, again, because of the cultural ways of abbreviating. But then down below, you've got a 3rd representation for that business, and one of its nearby neighbors, and they're really only 2 letters different. So this is just showing that it's a really hard problem to try to track people, addresses, names of organizations, et cetera. And of course, we've done a lot of work lately in Far East languages, bringing in consultants for linguistics and cultural understanding of like nicknames. So a lot of this support, but it's a very hard problem to handle globally. And because of that, one of the things that we see, and this is just kind of a pitch for Senzing here, but it's very true, we do run into a lot of cases where people said, hey, let's do fuzzy string matching on our database. That's probably good enough. And you find out once you hit the globalization problems, it's not. So we typically see a nonlinear ramp on buy to build ratio. And after a few years, and the VP is looking that you've put in $30 million into your project and you're really not there yet, then typically they're looking to buy something instead. The way that this SDK works, it's JSON in and JSON out. It's just an SDK. There's no platform. A recent wrapper that we did in Python, it's 2 lines of Python. It's pretty simple to implement. One of the things about us is that because of the audits, particularly working for a lot of defense and intelligence worldwide, we only do this one SDK. We don't do any other products. We don't do any professional services. Our customer support is free. It's run by the engineering team. All of our prices are published publicly. We just have to be able to make sure that when a new release of the code goes out, we can pass through the audits very quickly to get the code out into production and into these highly secure environments. And by virtue of that, then we end up partnering with so many different, actually a lot of people here in the room. We partner with many organizations as system integrators and OEM, et cetera. Here's an illustration of calling the SDK in one way. There are SDKs for Python, Java, and .NET, and we've got a lot of tutorials about this. And I'll skip through this in the interest of time. There's a few patterns. I know this is getting more into the engineering details, but there's a couple of design patterns. One of them is that when you're doing ETL of a lot of different structured data sources, you peel off the PII features and you run it in bulk. And then you generate, essentially, we like to think of it as kind of a backbone for constructing a knowledge graph. So that would be more of like a bulk pattern. But in production, once you've loaded your data, then you'll typically see more of an iterative pattern where new data updates come in, you'll peel off the PII and make a round trip and then go back and update wherever you're pulling your graph together. But there are other patterns as well. We're doing a lot of integration work with using embedding models and language models. And so here is something we've worked on pretty recently of basically taking what would be formerly a lot of green screens at a bank, or from our SDK, it looks more like a lot of different JSON documents. How can you take and summarize those into something that an analyst can read quickly to, again, bring the problem back to human scale? Because the threat actors are intentionally making this beyond human scale. I'll scoot through this, but we work with a lot of large organizations, both in public sector as well as in finance, financial services, and a number of different partners, again, many friends here in the room, and certainly a lot of work with data providers, and we do have some examples here of different types of data sets that we work with commonly and how we're supporting them in terms of their metadata descriptions. That's where it starts to fit in with semantic layer. All right, so I think the slides are a little off. I don't know if there's any way to adjust down, if it's possible to re-register the frame on that. If not, I'll talk through it. Actually, let's take this line down the bottom. I love this. This is from Abhishek Nagaraj out of Berkeley. Think of data as an imperfect map of the underlying entities. Oh, perfect. Thank you. Okay. Okay, so I'm going to talk about something called ERKG, Entity Resolved Knowledge Graphs. It's just a term that we've come up with, but the idea is how does entity resolution fit into the context of knowledge graphs? And then where does this fit in a semantic layer practice? And so really we are focused on the structured data and how we can build that out, again, to build more of the backbone for a graph. But it also helps inform how you can handle bringing in contextually what you extract out of unstructured data. And to that point, I really appreciate this quote here from Abhishek Nagaraj, data as an imperfect map of the underlying entities. Another way of saying that is if you look at a collection of data sets, somewhere in there, there are nodes, there are relations, there are properties, there are all the points to create the building blocks for generating a graph. And identifying the non-obvious connections that may have been lost because of schema, like what Ben was talking about earlier this morning, that's really a lot of the game. So when we run entity resolution, then the output here is literally we're generating these elements, these building blocks for graphs. We get entities, relations, and properties coming out. Again, when you get the entities as an overlay on the data records that provide evidence, but then you get probabilistic connections between the entities. Ones that are related, they might be the same, we don't have enough evidence yet. Or they might be a family member, something like that. And that's where we get into the semantics. So how many people here have ever worked with WordNet? OK, great, a few. So I'm a language nerd. Done a lot of work with natural language. WordNet is a kind of thesaurus that we've had around for decades. It's a project out of Princeton. It's really helpful when you're doing any type of natural language understanding or building knowledge graphs, because you effectively use the thesaurus to help understand how do you connect the parts. And so what we're doing with entity resolution is to generate a domain-specific thesaurus. Another way of saying that is a business glossary. And so if you know that Robert Smith II and Bob Smith Jr. are the same person, they live at the same address, you have all this evidence to say they're the same, but one of them is also operating under an alias, Bobby Jones. Now you start to have the elements of what you would expect in terms of synonyms in a thesaurus. That's basically the analogy. And to that point, I've been working with a friend who I think actually used to work for EK, but Jessica Talisman has a series of articles about the ontology pipeline. And also, I'm working with my friends and colleagues at EK on also some work. Lula and I are preparing some things published. There's other things being published. But looking at where does a thesaurus, where does a business glossary fit into this practice of developing an ontology, this practice of semantic layer. And I'll show that in some illustrations in a bit here. There are some case studies here, recent one from Red Horse, work that's being done for DoD, and How on congressional transcripts, being able to build those into knowledge graphs using LLMs. Also, Aptitude Global, Linkurious, GraphRAG, Cannabiz, et cetera. This is the thing that I want to point out as a graph technique, what we see being used as a general pattern for anti-fraud, but also, again, how can you really identify your best customers? So here, there's some data that comes from open sanctions and open ownership, and it's about a case that was about almost £1 million of tax evasion in South London. There was a chain of Papa John's pizza delivery, and so Abassine Badshaw and his spouse had a series of shell companies. This was prosecuted a few years ago. The idea is that data is sort of connected when you initially get it, but it's not all connected. Once you run entity resolution, though, Abassine Badshaw shows up as this really central node. He's orchestrating this fraud network. And so the steps are use entity resolution to pull the pieces together, use partitioning algorithms like Louvain or strongly connected components to bring that down to human scale, find out the interesting subgraphs per case. And then from there, you can run graph algorithms like degree centrality, and at that point, usually the people who are orchestrating will bubble up to the top. They'll be the most central nodes, kind of like PageRank. And then from there, you can take all this and run it through case management tools. So this is a case, a known case in anti-fraud, but you would do similar things if you're looking in marketing, say for householding. Right? So if you're in travel industry, hospitality, and you want to try to find out where people are maybe making registrations for hotels under their business account versus their personal account, trying to pull it all together into a graph, again, finding your best customer. We also do a lot of work really on the audit side. So there's a lot of EDA tooling to be able to find the chain of evidence. And more recently, we've been working on examples, open source tutorials, using LLMs to summarize this and come out with tables and paragraphs to summarize, so bringing it back to human scale for an investigator. I'm going to shoot through real quick here. Let me just show this one thing. So if you're talking about working with agents, working with GraphRAG, where we fit, again, is this kind of business glossary, a thesaurus. That's useful for being able to structure how you're going to build a graph. Really, kind of a backbone for the semantics of building the graph. It's a component that fits into your process for developing an ontology. The other thing, though, is a business glossary, a thesaurus, can also be used for entity linking. So it can also contextualize and guide how you bring in elements from unstructured data and how you pull them together. Let's see. We only have a few minutes, so I want to get to some discussion. OK, so let me shoot forward on this. I just want to show this one here. This is a graph illustration of the actual fraud in the Azerbaijani laundromat. So that's $3 billion of fraud, and you can see there's like 400 plus shell companies that were used to obscure the sources of the money, and then there are 4 shell companies where it was drawn out, the big ones in purple. So this is a kind of graph analysis for being able to do forensic accounting on this particular case. And I think from there, I have a lot more resources. If you want to grab this graph, there's some recommended books. And I do a podcast every month with luminary individuals in this field. And so please reach out and connect with me if you have any questions. Thank you very much.